In this module, we will look at the landing gear system of the aircraft. We will start out with a system overview. Next, we will take a look at the landing gear system, the nose wheel system, and the brake system. Finally, we will review the controls and indicators associated with the landing gear and brake system. The aircraft has a conventional tricycle landing gear. The nose landing gear retracts forward, whereas the main landing gear retract inward. Gear doors enclose the gear when it is retracted. Each main gear incorporates an oleopneumatic shock absorber and two wheels. The tires on the wheels are tubeless. The landing gear system is powered by the green hydraulic system. In the event of a failure of the green hydraulic system or an electrical failure, the landing gear can be extended by a gravity extension system. A gear position detection and indication system supplies the necessary information to the multifunction computer, or MFC. In addition, the system provides gear position information to the crew. The MFC manages the extension and retraction of the landing gear. Each main gear is equipped with two sets of multi-disc carbon brakes. The braking system incorporates an anti-skid system as well as an emergency and parking brake system. The brake system is supplied by the green hydraulic system. However, the emergency parking brake system is powered by the blue hydraulic system. The anti-skid system provides maximum stopping performance based on wheel slip, brake and tire wear, and runway conditions. In addition to the anti-skid function, the system provides touchdown and locked wheel protection. Each main gear wheel incorporates a fusible plug to provide protection against tire bursts due to overheat. These plugs will release the tire pressure in the event a wheel temperature exceeds 177 degrees Celsius. The multi-disc carbon brakes on each main gear are operated by hydraulically powered pistons. Each brake is equipped with an automatic adjuster, an overheat detector, and a wear indicator pin. A nose wheel steering system provides steering capability to the aircraft on the ground. The nose wheel steering provides up to 60 degrees of steering to either side. The nose wheel steering system is powered by the blue hydraulic system. The controls and indicators for the landing gear system are located on the overhead panel and the flight instruments panel. An emergency gear handle is used to gravity extend the landing gear. The handle is located on the aft side of the center pedestal. Control of the nose wheel system is provided by a nose wheel steering tiller on the captain's side and a nose wheel steering switch which is used to enable the nose wheel steering system. The brakes are controlled by the rudder pedals and the emergency parking brake handle. In the event brake temperature is excessive, a brake temperature indicator light illuminates on the flight instruments panel. Brake pressure is indicated on a brake accumulator pressure indicator located on the flight instruments panel. An anti-skid control panel is used to control and test the anti-skid system. The anti-skid control panel is located on the flight instruments panel. Additional controls are located on the lateral maintenance panel. These controls consist of a weight on wheel selector, a failure readout display, and a brake temperature test push button. These controls are normally used by maintenance. Two independent position detection and indicating systems provide gear position information and control the landing gear extension and retraction operation. In addition, these two systems provide landing gear warnings under certain conditions. Each system uses proximity sensors to supply downlock and air-ground signals. Uplock signals are provided by mechanical limit switches. The primary system is controlled by MFC Module 1A. The gear position indication on the flight instruments panel is derived from the primary system. The primary system is powered by the DC standby bus. The secondary system is controlled by MFC Module 2A. The gear position indication on the overhead panel is derived from the secondary system. The secondary system is powered by DC Bus 2. The landing gear can be considered down and locked as long as one set of landing gear position indicators are green. Weight on wheels information is supplied to numerous aircraft systems such as the pressurization system, the anti-ice system, and others. Weight on wheel system 1 is managed by MFC Module 1B, and weight on wheel system 2 is managed by MFC Module 2B. Weight on Wheels System 1 is powered by the DC Emergency Bus, and Weight on Wheels System 2 is powered by DC Bus 2. The landing gear is operated by the landing gear handle located on the flight instruments panel. The handle must be pulled out in order to move it. The landing gear cannot be retracted if one gear shock absorber senses a weight on wheels condition. Click on the landing gear handle to continue. Placing the landing gear handle to the up position sends a signal to the MFC to retract the landing gear. In this case, the MFC electrically controls a landing gear selector valve located in the left main gear fairing. The valve supplies green hydraulic pressure to unlock each gear. After unlocking, hydraulic pressure is then supplied to the retraction side of the landing gear actuators. The extension side of the actuators is then used to return hydraulic fluid to the reservoir. When the landing gear lever is placed in the up position, hydraulic pressure is also applied to the main gear brakes to stop wheel rotation. The main landing gear doors are mechanically connected to each main landing gear. During the retraction sequence, the landing gear door will unfold so as to enclose the main landing gear when it is retracted. The main landing gear doors are open when the main landing gear is extended. You can use the landing gear handle on this screen to extend or retract the landing gear and see the operation of the main landing gear doors. The nose gear doors are also mechanically driven by the nose landing gear. The nose landing gear has 4 doors that completely enclose the nose landing gear when it is retracted. When the nose gear is extended, the 2 forward doors will be closed and the 2 aft doors will be open. Once a landing gear is retracted, it is mechanically held in the up position by an uplock mechanism, and hydraulic pressure is removed from the retract side of the gear actuator. The landing gear is extended by placing the landing gear selector in the down position. The MFC will supply green hydraulic pressure to retract the uplock mechanism. After the uplock mechanism is retracted, the MFC will then supply green hydraulic pressure to the extend side of the actuators, and the retract side will be used to return hydraulic fluid to the reservoir. Once the main gear is extended, the main landing gear is mechanically maintained in the down position by means of a dual alignment folding side brace. Locking springs provide a second method of alignment and ensure that the main landing gear is locked down in the absence of hydraulic pressure. The drag brace is monitored for down locking indications. The nose landing gear is held in the extended position by a similar type of brace. The lower strut provides lugs for tow bar attachment. Once a gear is locked down, hydraulic pressure is removed from the extend side of the associated landing gear actuator. An emergency extension system allows the landing gear to be extended in the event of a normal system failure. Pulling the emergency landing gear extension handle on the aft side of the center pedestal mechanically releases the uplocks and allows the landing gear to extend by gravity and aerodynamic forces. During an emergency extension, the main landing gear extension is assisted by gas actuators and springs, and the nose landing gear extension is assisted by a mechanical extension device. Once all gear are extended, they are locked in place by the braces. The nose wheel steering system is powered by the blue hydraulic system. Steering is accomplished by means of a tiller located on the captain's side panel. Hydraulic pressure is supplied through a nose wheel steering selector valve that is powered by the DC emergency bus. The tiller provides a steering authority of 60 degrees either side of center. In the absence of hydraulic pressure, the nose wheel steering system can be deflected up to 91 degrees either side of center during towing operations. A swivel valve removes hydraulic pressure from the steering system when the nose gear is not locked down. A solenoid valve will also remove hydraulic pressure to the nose wheel steering system when the main gear and nose gear shock absorbers are not compressed. In this case, the nose gear will be mechanically centered. You should note that the nose wheel steering will be available after all gear shock absorbers are compressed. If one gear leg comes off the ground after all the shock absorbers have been compressed, the nose wheel steering will be maintained as long as at least one gear stays on the ground. Nose wheel steering is controlled by the nose wheel steering switch located on the captain's side panel. The switch is guarded in the on position. In the on position, the steering solenoid valve is armed for operation. The valve opens when steering is commanded. The aircraft can be steered in the event of a loss of the nose wheel steering system. In this situation, steering is achieved by differential braking or using differential thrust with the engines. As discussed previously, each main gear wheel is equipped with multi-disc carbon brakes. They are operated by one set of 5 hydraulic pistons. The main gear brakes have 2 modes of operation: the normal mode and the emergency and parking brake system. In the normal mode, the main gear brakes are powered by the green hydraulic system. Brakes are applied by the brake pedals that are incorporated in the rudder pedals. The emergency and park brake system is powered by the blue hydraulic system. This system is controlled by the emergency and parking brake handle. If the brake handle is placed in the center notch, approximately 500 psi of pressure will be available for braking. Additional pressure can be applied by moving the handle aft another 1/2 inch when the aircraft is below 60 knots. Beyond this point, the full 3000 psi of pressure will be suddenly supplied, so this position should not be used while the aircraft is moving. The FCOM dictates that the tires should be visually inspected prior to takeoff if the emergency and park brake system was used while the aircraft was above 20 knots of ground speed. This may have caused one or more tires to overheat and lose air pressure due to the melting of a fusible plug. In the event of a complete hydraulic failure, an emergency brake accumulator will supply sufficient hydraulic pressure for at least 6 brake applications. The normal and emergency and park brake system supply pressure to the wheel brakes through shuttle valves. The shuttle valves will direct available hydraulic pressure to the brakes. An anti-skid system provides protection against tire skidding as well as locked wheel and touchdown protection. The anti-skid system is available as soon as the landing gear is down and locked, and as long as the aircraft ground speed is greater than 10 knots. The anti-skid system consists of a control panel located on the center flight instruments panel, an anti-skid module, a control box, and 4 wheel speed transducers that measure wheel speed. There is 1 transducer for each wheel. The purpose of the anti-skid system is to control brake pressure to each brake so as to achieve the maximum stopping performance. During the braking phase, the anti-skid system calculates an optimum deceleration schedule and adjusts the amount of hydraulic pressure to the brakes so as to achieve that desired schedule. Hydraulic pressure is applied so as to adjust the tire speed to the reference speed required for the deceleration schedule. If the system senses that a wheel is skidding, the anti-skid system will release hydraulic pressure to the associated brake to alleviate the skidding. The anti-skid system provides locked wheel protection by comparing the wheel speeds of the inner pair of main gear wheels and the outer pair of main gear wheels. A locked wheel signal is generated if the anti-skid system detects a speed differential between the 2 wheels that is in excess of 50%. This signal will result in a release of brake pressure to prevent wheels from locking. Locked wheel protection is available when the ground speed is above 23 knots. When the main gear shock absorbers are compressed at touchdown, the anti-skid system will prevent the brakes from operating for the first 5 seconds after touchdown, or as long as wheel speed is below 35 knots. The purpose of this system is to prevent the use of brakes prior to wheel spin-up on low friction pavements or if there is a light load on the wheels. In the event of a failure of the anti-skid system, the touchdown protection system is inoperative and the brakes are directly controlled. The landing gear is extended or retracted normally by the landing gear lever on the center portion of the flight instruments panel. The handle must be pulled out in order to raise it or lower it. If the handle is placed in the down position, a red light will illuminate in the handle as long as the gear is not sensed to be in the down and locked position. 3 gear position indicators located above the landing gear lever illuminate green when the associated landing gear is in the down and locked position. These indicator lights are controlled by MFC 1. The On Lock caption illuminates red when the associated gear is not locked in the position selected by the landing gear lever. It will also illuminate if the aircraft is on the ground and the associated uplock box is not in the open position. Landing gear position is also indicated by 3 similar lights located on the overhead panel. These lights are driven by MFC2 and they operate the same way as the ones on the landing gear control panel. As discussed previously, the landing gear is considered to be down and locked when either set of lights are illuminated. The emergency extension handle is used to mechanically unlock the landing gear when they are retracted. When the handle is pulled, the uplocks are released and a valve is opened to allow fluid in the lines to return back to the reservoir. After that, the gear falls by gravity, assisted by a compressed gas strut. The nose wheel steering switch controls the nose wheel steering system. When the switch is in the guarded on position, the nose wheel steering solenoid valve is armed for operation. When steering is commanded, the steering valve will open and allow hydraulic pressure into the system. Placing the switch to the off position disables the steering valve and the nose wheel steering system is depressurized. The steering tiller is used to direct hydraulic pressure to the associated side of the nose wheel steering system. Up to 60 degrees of steering is available. The nose wheel steering system will center after liftoff. The emergency and park brake handle controls the emergency and park brake system through an associated brake metering valve. The handle is spring-loaded to the off position. The emergency brake is usable at speeds up to V1 and supplies equal hydraulic pressure to all brakes. Pulling the handle aft supplies a metered amount of blue hydraulic pressure. In the parking position, the full amount of pressure is applied through the brakes. It is important that you understand that the emergency and park brake handle will brake the aircraft without any anti-skid protection. When the brake handle is not in the brake off position, the amber parking brake light illuminates on the crew alerting panel. A brake temperature hot light illuminates when at least one brake temperature exceeds 160 degrees Celsius. In addition, a single chime will sound, both master caution lights will flash, and the wheel light illuminates on the crew alerting panel. The brake temperature system is powered by the DC standby bus. The brake temperature system can be tested by the brake temperature test push button on the lateral maintenance panel. When this button is depressed, both master caution lights will flash, the hot amber light illuminates, the wheel light illuminates on the crew alerting panel, and a single chime will sound. The brake accumulator provides a reserve supply of fluid under pressure for parking and emergency brake use in case the blue system pressure is lost. It is designed such that a nitrogen precharge is separated from hydraulic fluid by a piston. The accumulator is then further pressurized by blue hydraulic pressure to 3000 psi. Accumulator pressure is indicated on a triple pressure gauge. The top of the gauge indicates the emergency and parking brake accumulator pressure and is normally 3000 psi. The left and right needles indicate the blue and green hydraulic system pressures respectively. The gauge is powered by the DC standby bus. The anti-skid system is controlled by the anti-skid control panel located on the center flight instruments panel. The anti-skid push button controls the operation of the anti-skid system. Anti-skid is available when the push button is pressed in. The anti-skid is off if the push button is released out. In this case, the off caption illuminates in the push button. The anti-skid system is monitored by 4 lights located above the anti-skid push button. A fault light illuminates in the event of a failure of the associated anti-skid channel. In this case, the anti-skid function for the associated wheel is lost completely. A test push button can be used to test the anti-skid system when the aircraft is on the ground or in flight. The test should not be done if the parking brake is not set when the aircraft is on the ground with the engines running. On the ground, the test is performed by applying brakes through the brake pedals. The test is initiated by pressing the push button. The test will last approximately 6 seconds, and during this time, the brakes will be compressed and released. In addition, the fault lights will also illuminate during the test. A failure is indicated in a particular channel if the fault light remains illuminated after the test. It should be noted that the anti-skid test mode is inhibited when the aircraft is on the ground and the ground speed exceeds 17 knots. This concludes the landing gear and brakes module.